This is Shakil Ahmed. In this tutorial, we will again discuss about analyzing data on Likert scale. We will show how we can find the Likert scale data in terms of ordinal data, in terms of order, not just a factor or a numeric variable. And then we can tabulate the ordinal data, the Likert scale data, and then visualize the Likert scale data, and then find the summary statistics and their confidence interval. So these are basically we need to do when we are analyzing or when we are describing a, a data on Likert scale. So let's start. I have again taken the data set from Kaggle that is on self-esteem scale. Responses consist of 10 questions and some demographic questions like age and sex of the respondent. So we have a data as a data frame, and I have just tried to exclude the variable responses with zero. So you can just run this command. This will include exclude the if there is any response with zero, it will exclude. So we have just four responses, one, two, four, and I have just extracted three variables and converted them to the ordinal scale. So this is the variable name equal worth as others. I have just renamed this variable. Uh, just extracted this variable from the data frame, and the order is equal to true. It means I'm just converting it into orders, and these are the levels, and you can see just run this. You can see now we have data on 1 to 4, and the data type is on ordinal. Similarly, we convert the next to other variables, and you can now see the structure. We have all other variables on numeric scale, and these three variables. The country of the respondent is in character, mostly from the United States, and uh, the rest of the three variables which we have created on ordinal scale is in order factor. Basically, these are factors but ordinal. And whenever you have ordinal data, then you can't find direct these statistics just like a numeric variable. So we are dealing with ordinal data that is on Likert scale from 1 to 4. Here you can see 1 is less than 2 is less than 3 is less than 4. And these are just levels, not the numerical values. 1 and 2, 3 means we have just level of the factors, not we can say that this is the value is 2 or the value is 1. You can name anything A, B, C, D. You can label just like that. But it is confirmed that 1 is less than 2 and 2 is less than 3 and 3 is less than 4. So we can see the dimension of data. We have 17 variables and 47,000 responses, and we can just tabulate the variable equal worth as other. This is a variable measured on Likert scale. So we can just use the x steps and the approximate sign, and then this is called the tilde sign, and then the variable name, and data is data frame. In this data frame, we have this variable, so we can check. You can see the table x tab, and these are the values levels, and these are the frequencies. We have this much frequencies in the data. You can also include the percentages as well. But for now, we can just make a box plot, bar plot for this data. Usually when you have ordinal data, then you will present a bar plot rather than a pie chart or other type of plots, as it will show the ordering of data, and you can see how many frequencies are there in different ordinal categories. And we can just do it using the bar plot and then x tab. Basically we are using this table with x values and the frequencies, and these are the titles and these are the color of the bars, and you can set to some other color. So we can just run. So we have frequency 0 to 10,000, and this is the Likert scale, and these are the frequencies 1 to 4, and we have most of the responses in and the category 3. And we can make a box plot that will consist of the minimum value and the maximum value and the median and the quartiles, first and third quartile. So let's see, this is for the same variable we have just constructed a box plot. This consists of this is basically the 92.5 percentile, and this is Q1, and Q2 is almost same as Q1, and this is Q3, and we have very small data or no data beyond this limit. So the 4 is basically the third quartile as well as the maximum value, as we have just discrete values. So it's taking 4 as the uh, last value and the third quartile as well. And we can also find the tables for by gender or by other some other variables. We can see this is the X tab for gender. You can see the gender is 0, 1, 2, 3. There are 4 types of genders. Uh, 3 mostly unknown case, and this means not referred to say or might be transgender. I don't know exactly, but these are the males and females. We have a higher number of frequencies in these two groups. So this is just a frequency distribution by gender. And then we can find a bar plot by gender. This is the bar plot by gender. Just the legend is overlapping the responses, but we can shift the legend using the position of the legend here. Uh, from We can just remove the legend from the bar plot over the bar plot, and we can specify the position for the legend. You can just check the documentation of bar plot using bar plot. Just write bar documentation for bar plot function, and you will get the answer. And we can find again the box plot by gender. I will get 2 box plots for male and female separately. Uh, Now it's clear, this is the unknown category, this is the male category, and this is the female category, and this is the other category. And we have distribution of different responses in the 4 categories. And then we can find the median of the variable using again this library. The median is 3, and using the library FSA we can find the summary statistic This is also computing the total number of observation and mean, standard deviation, minimum, although we don't prefer to find the mean in this case, and we usually report the median and interquartile range for such type of data. And then we can construct a 95% confidence interval for the median using Wilcoxon statistic. You can just find we just enter the data, and the alternative is basically we are using a two test for Wilcoxon test, and the correct is equal to true. It means we are using a correct version, that is exact version of the Wilcoxon cyanide test, and the confidence interval is true. Confidence level is 95. We are constructing confidence interval at 95%. So let's see. It's running. It's just taking time, as it will first rank all these values and then compute the test statistic and then find the confidence interval. So the confidence interval is again at 3 for both the cases, although median is also 3 and the confidence intervals are also 3, 3.00035 and 3.000. So this is just we need to find while we need to report while analyzing uh, data on Likert scale. We first define the X step, and we can just report the frequencies in each category and with percentages. And then we need to report the median, and then uh, the confidence interval for the median. Or you can just report median with interquartile range. And then you can visualize using bar plot, and you can also show the summary statistic using the box plot. And that's all about the analyzing the Likert scale. Thank you.